Hi everyone, welcome back to CI Math 389. Today we are going to talk about lesson 10, statistics, the input interpretation of data. The graphical representation of data. The first one we want to talk about is line plots. A dot plot for the data test score consists of a horizontal number line on which each score is denoted by an X above and corresponding number line value. So here we have a number line, 5, 10, 15, we have number line like this. And then if we want to have organize the data and we put on the X on the top, we put on the X on the top, we have put on the X on top, okay? And that would be, the line plot, okay? This is a kind of representation of data. And then here's another way we can represent the data called a stem and leaf plot. And to draw a stem and leaf plot, we let the tens of the score be the stem and let the units digit be the leaves, okay? So let's say this is a data set, all right? This is a data set. Now we have a data like this, and how can we make it as a stem and leaf plots? So we have one column is a stem and the other one is a leaves. So stem and leaves. So this is a ones. This is a tens. All right, so ones and tens. So therefore, we have 5, okay, 0, 5 right here. 10, 10, which is 1, 10, and 1, 0, right? Now what about 10, another 10, and we have 1, 10, and 1, 0 there, okay? How about 15? 15, it will be 1, 10, and 1, 5 there, right? And then what about 20? All right, 20 will be 2 and 0, right? And then therefore, we have how many 0 there? We have a 20, 20, 20. So we have a 20, 120, 220, 320, okay? Something like this. The next 25, okay? We have stem is 20, so we have 2 and then 5, okay? And then how many 25 are there? We have 125, we have 225 there, right? The last one is a 35. 35 is the stem is a 30, right? And then the leaves, which is 5 ones put on here, 5, right? So therefore, this is called a stem and leaf. And then this is how we do the stem and leaf, okay? The next is histogram. In a histogram, score are grouped in intervals, and the number of a score in each interval is indicated by a height of a rectangle constructed above the interval. All right. Again, I'm gonna use the same, data sets like this. And how can I create a histogram? A histogram, you see here a number of score in interval. What does this mean? That means, we group intervals. So I can see the number, the lowest number is 5, and then the highest number is 35, right? So I will group the interval. So we group the interval here, from here, every 5, right? From 0, 1, 2, 3, 4. Okay, that would be one group, right? The next would be 5, 6, 7, 8, 9, right? Next will be 10, 11, 4, 10, 11, 12, 13, and 14, right? And so on. We group the intervals, okay? Every 5 is interval like this, okay? So, and what about a height? Height is a frequency. C5 is a frequency, all right? We have a frequency, okay? All right, that will be the height, all right? Height will be the frequency. So since this is, the frequency you can see only 20 is a 3, so therefore I have a frequency for the maximum for a file like this, right? So now I can create a histogram like this, histogram. So we have a 1 5, how many 10? 2 10s, so there are 2 10s there, right? And then how many 15? We only have 1 15. And how many are 20? We have 3 20 like this, okay? We have 3 20 right here, right? And we how many? All right, this is an example of a line graph, okay? So the data of a construct by joining the midpoint of the top of rectangle in the figure by line segments. So this is example of line graph. Okay, now here is a histogram and line graph of the Heights of Boy and Eisenhower High School, something like this. So we have histogram and we have line graph. You can see it in this example. Okay. Now the next is a bar graph. Bar graphs are often used in conveying information about so-called categorical data, where the horizontal scale represents some numerical attribute. So you can see bar graph very similar to histogram, but the a little bit difference is this is a categorical data. It's not like histogram. Histogram has a continuous data. Now continuous data we have to group an interval, but here we don't group interval. So this is a bar graph. So this is examples of student favorite juices. Okay, so you can see this is a bar graph and very similar to histogram, but it's different because histogram they join together because they have group they have connect to each other because they are intervals. Okay, and the next is the pie chart. The number of degree in angular measure of each part of chart is appropriate fraction of percentage of 360. So you can see here's a pie preferences, and then we used a pie as 100%, right? Then cherry is a 23% of this. Pumpkin is 30% of this. How about apple? 36. How about pecan? And so on, 8%, something like this. So this is a kind of another way we can see the data. All right. We can organize the data like this. Okay. The next one is a pictograph. A pictograph is a picture of a set of small figure or icon used to represent data and often represent trends. All right. So here is, let's say we can read this, we can teach younger children like this, we can teach, low grade level for the children like this. Like here, 1 apple represent 10 apple. So how many for this? Oh, that will be 30, right? And then what about half? Half will be 5. So that will be 10, 10, 5, that'll be 25 like this, all right? So this is another way to show the pictures, okay, of the data, okay? Now choosing a good visualization, line plus summarize relatively small sets of data, grades in class, heights of student class, first month of student in a class, and so on. Now what about standard leaf? Standard leaf is for essentially the same purpose as line plots, especially useful in comparing small data sets. Then histogram summarize information in large sets of data that can be naturally grouped into intervals. So we talk about this, the difference with histogram and bar graph is, they look like very similar, but in histogram, they have the group in the intervals. Okay. The line graph summarizes the trend over time. You can compare the time, okay? The pie chart represents the relative amount of a whole. And what about pictograph summarizing relative amounts trend and data sets useful in comparing quantities. Okay, so those are, you know, the way we can choose, you know, we can see which one is a good visual for the data. All right. Thanks for watching, and you have a great day.